I'm Nicholas Codina of the group The Low Quick Starts That Could, and today I'm going to be presenting our technical report on standard efficiency versus high efficiency HVAC systems. For the contributions, I did mostly writing and editing. We stuck true to the copy numbers for what we noted in the progress report. We kind of varied a little bit just from the flow of the project though, but for the most part we stuck true to what we noted in the report. The problem statement for our report is just basically comparing the long-term savings from the highly efficient HVAC system and just seeing if the cheaper energy bills and all the benefits that go along with it justify the higher upfront cost. And for our target audience, which is an established commercial company for like offices and warehouses in the Tempe or Phoenix area, we're basically just seeing what would be best for them in their current situation. The HVAC models we are comparing are the TR14, which is the standard efficiency, and the TR16, which is the high efficiency model. The TR16 features a higher efficiency compressor, quieter operation, HRI certification, which is like a green certification, as well as relatively longer warranties than the TR14 just due to its higher quality parts, and it just helps out with the maintenance and stuff. Investigative method in our assumptions throughout the project. The units, both the sears, were of comparable size, each weighing about 5 tons. The rate of return, we were looking to find a point in time where consumer will be able to reap the benefits of the higher upfront cost and the highly efficient. The analysis of electricity fluctuation, we were looking to see how this will affect the cost of the use of the system and at the point in which a consumer will reap the benefits under the assumption of a 1.07% increase per year based on the electricity cost of the last year. The maintenance cost was assumed to be about the same, which made it just about negligible in our calculations. First, for our results, the first graph here shows cost of each of them throughout different years. As you see in the beginning, you pay higher upfront costs and higher efficiency, and then just about, you can see at about the 15-year mark is when you start to reap the benefits of the highly efficient. These two are showing the net present value. The graphs both show the 5, 10, and 15-year periods. On the left we have the standard efficiency, and on the right we have the highly efficient. And you can see clearly in both how the longer you have the system, so the green at the 15-year mark, the more money you're going to save. In our recommendation after the project, we concluded that the highly efficient system is the unit to purchase for our specific target audience. It requires less maintenance, it lasts longer, it's greener, which is better for the environment, and another bonus outside of cheaper monthly costs is that you get SRP discounts, which is just in addition to the cheaper monthly costs. The one stipulation we had was if the consumer was by chance only having the HVAC system for around 13 2/4 years, then they should just stick to the standard, because that's at the point where you make your money back for the highly efficient. But with HVAC systems on average lasting 25 years, it's kind of pointless to imagine it that way, and most companies and warehouses, they plan to have a building for more than that time anyway, so we added that as a stipulation, but you can kind of count on it anyways, and we overall land on the conclusion to purchase a highly efficient HVAC system.